Okay, so today we're going to be looking at a question from the higher paper 2018 Edexcel. It's a question which combines substitution and completing the square. So it's a good mix of topics, and it's quite tricky at first glance, but actually when you break it down it's not too bad. So it's a good question. Okay, so the first thing you'll notice here is that they haven't actually given you the equation of the curve. They've just given you the form that it's going to take, and you need to find out what these missing integers are. Ultimately, what we're going to be aiming to do is to find the turning point, which essentially means the moment at which it goes from a decreasing function to an increasing function. So that point there. Now, to do this, first thing is we're going to have to find the equation of the curve. So how might we do that? Well, we have 2 points that we know lie on the curve. These two here, 0, -5, and 5, 0. So the first thing we can do is if we substitute in the 0, -5 points, that means that when x is 0, y is -5. So this point here basically means that when x is 0, let me just change that to an equals. X equals 0, y equals -5. So let's substitute that in to our the form of the equation that we've got, and we would get -5 equals 0 squared plus a times 0 plus b. So what does that tell us? Well, essentially we can see here that this part is 0, a times 0 is 0, so the only thing on the right hand side that's not 0 is b, so b must be -5. Okay, so b equals -5. Give myself a bit more space here. Don't worry that we can't see the graph, that's okay for now. So b equals -5. Now let's take that then and rewrite what we know so far. So we know that y equals x squared plus ax -5, because now we know that b is -5. So now we turn to the other point. The other point tells us that when x equals 5, y equals 0. So now we can substitute that in, and this gives us y equals 5 squared plus a times 5, 5a essentially, -5. So y equals 25 plus 5a -5. So, and should have put this in before, y of course is, as we know, equal to 0, so we can just actually write 0 here. So now, rearranging that bottom equation, give ourselves some space, rearranging this, we can see that if I take all the numbers over to the other side, I'm going to have -20, so I've subtracted 25 and added 5. -20 is equal to 5a, so 5a, a must equal -4. Okay, so now if we just go back to the original problem, we can see that once we've got a and b, we can see that we can write this as y equals x squared plus negative 4, because we found out a was negative 4, negative 4x minus 5, because b was minus 5. So now we're in a position to find the turning point of the curve. So to do that, whenever you see a question asking for the turning point of the curve, that should make you think, I need to complete the square. So how do we complete the square? I'm just going to change colour for this bit. It's sort of second step in this process. So to complete the square, the most important thing to look out for is the coefficient of x. So in this case, negative 4. So what you need to do is half that, so half of negative 4 is negative 2, and then put that with x in one bracket and then square it. So here we're going to get y equals x minus 2 squared. Okay. Now, x minus 2 squared, this is our square, but we need to complete it. So if I were to expand this out, what would I get? I would get x squared minus 2x minus 2x, so minus 4x. So far, so good. It's matching up with our expression above. But then I would get plus 4, because minus 2 times minus 2 is 4, so plus 4. But in the original expression, you can see that we actually had minus 5. So what I would need to do to complete the square would be to add this extra negative 9. Negative 9. So that's the completion of the square there. So this bit here is crucial. That negative 9 takes us back down to minus 5. So now this expression here is equivalent to the curve, the x squared plus minus 4x minus 5, but it's been expressed in a form that takes a square and then a bit to complete it. So what does that tell us? Well, it tells us that the lowest y, the lowest that this y value can possibly go is negative 9, because a square, the x minus 2 squared bit, the lowest that can ever be is 0. Because whenever you square something, it's either going to be 0 or a positive number. So the lowest it could be is 0. So that means that the lowest y can go is negative 9. And of course, that means that our turning point here, the lowest that can go is negative 9. So that must be where it starts to turn, negative 9. But where on the x-axis does that happen? Well, that will happen when this bit here, the x minus 2 squared, is as low as it can go, i.e. 0. When will that be 0? Well, when x equals 2, because 2 minus 2 is 0. So that means that x must equal 2. So then we have our coordinates. The coordinates would be, I'll just put this in the right place. So there's our answer box. So the coordinates would be, my black pen for this, 2, negative 9. There we go. So have a rewind and have a look back through this video. If there's any steps that you didn't understand, then let me know. Hopefully those steps are clear. Sometimes you'll get a completing the square question which doesn't have this whole find A and B bit at the start. It will just give you the equation straight away. But this was quite a good one because it had that double step, which most of the hard questions on the GCSE papers have. So, okay, thanks for listening, and I'll see you next time.